here's an alternating series and we're supposed to find the sum accurate to 4 decimal places. So that means that when we find the error would have to be 0.0000, so it would have to have 4 zeros for the error, and then the 5th decimal place could be as much as a 9. So that way, if this is the error, it's going to be off by 0.00009, and the first 4 decimal places would be accurate. Okay, that's one idea. The other idea is that if S is the sum, and you use a partial sum to estimate it, then that error is going to be less than or equal to the next term. One of the great things about alternating series. So this side is saying what the error is, and we're saying that the error at most could be 0.00009. And to solve for k, I'm just going to change the inequality to an equal, saying basically, what if the error was as much as possible, as much as is allowed? With this series, I know that it's an alternating series, so I don't really need to use the -1. Just replace n with k plus 1. And now we need to solve for k. Since we have an algebraic function and an exponential function in the same problem, we can't really use algebra to solve. So we're going to use the calculator. So basically I'm looking at this. Let me get a pen. I'm looking at this as a function. I'll put that in the calculator, and then I'll see when does it equal 0.0009. And I know that the calculator is going to use scientific notation. So this would be 1, 2, 3, 4, 5 decimal places. So when it's 9 times 10 to the -5. Or on the calculator, it would say 9 with the exponent of -5 in scientific notation. Okay, let's go over to the calculator. And I did my work beforehand and typed the function in. And then I'm going to make a table. So go to second table set, starting at 1, going up by increments of 1, and then look at the table. And I can see that right here is the first time it has the scientific notation, meaning 10 to the -5. So that means that it's going to be 6. Now keep in mind that it was basically putting a 6 right here and a 6 right here. No, I typed in k plus 1. So actually that was k equals 6. So just ignore that purple part because I'm not going to redo the video just because I did that purple part. All right, so the calculator said that was when it was a 6. So then we need to do the sum of the sequence, and it's alternating, so -1 to the n, and then it was just an n on top and a 5 to the n on bottom, and then go from the directions say start at 1, so go from 1 to 6 in increments of 1. And so go to the home screen and list. Under math, there's the sum. Go back to list. Under operations, there's the sequence. And then it was alternating, so I need -1 raised to, calculators right now using x, that's fine. And then there was the x on top divided by 5 raised to the x. And then x is the variable, go from 1 to 6. If you stop right now, the calculator will assume that you meant increments of 1. Or you can also say comma in increments of 1, and we get the same thing. And the directions did say go to 4 decimal places, so I suppose I need to change this to go to 4 decimal places. which on this screen is sometimes difficult to get it to change. There we go, 4 decimal places, and then just redo that so that we have, it's a 1388 with a negative and a decimal in front. So it's a negative .1388.